So hello again, Anne, and welcome on this international webinar week. It's a pleasure to welcome you today, and thank you for having accepted our invitation. And thank you, Stephanie, for the connection. Before giving you the floor... Sorry?
It's not me, really, it's Karin.
Ah, Karin, okay, okay. Thank you. Before giving you the floor for a 30 minutes presentation followed by a 15 minutes Q&A, let me present you and the topic of your presentation in a few words. So, Anne, you are principal partner at Baumschlager Eberle Architekten. I hope the pronunciation is correct.
Yes.
In Austria. You are an architect graduated from the National School of Architecture in Paris, Belleville, and the University of Hanover in Germany, where you were born. In Germany, maybe not in Hanover,
no.
And where you teach also architecture. You've been living in France for 20 years, so you know well French people and France, and you started your career working for Dominique Perrault, architect. And 9 years ago, you joined Baumschlager Eberle Architekten as a managing partner to manage the Paris office and to sit on the board of directors. Baumschlager Eberle Architekten has 12 offices in Europe and in Asia. You have an extensive experience in the fields of town planning, architecture, and interior design. In particular, you have won numerous competitions, the 5-star hotel at the tip of the prestigious Ile Seguin in Paris, the Parisian Bridge building on the Saint-Denis Pleyel site, the Cité Universelle, and many others, and as well many projects in wood structure.
Yes.
As fervent follower of eco-construction, you are particularly attached to the principles of sustainable architecture at social, economic, cultural, and environmental levels. Of course, you are regularly invited as a speaker, and you have spoken in many conferences, COP21, MIPIM, Sustainable Energy Week, CIMI, Energy Meeting, and so on. Today, you are with us, so thank you again, and you will present us the 2226 concept, which is an office and apartment building in Lustenau, Austria, which works completely without heating, ventilation, or cooling. It's an alternative to the high technical equipped buildings of the last few decades. And you will explain us how to combine the comfort of our lives with a reduced consumption of resources. Han, the floor is yours, and thank you again.
Thank you very much, Frédéric. So I will try to share my screen.
Perfect.
Okay, thank you very, very much again. So bonjour and good afternoon. And again, thank you for the invitation. I'm very honored to be part of this event and for the presentation of Frédéric. And on behalf of Baumschlager Eberle Architects, I can say that we are very glad to get the opportunity to contribute to this conference, in particular to the question how we can combine the quality or the comfort of our lives with a reduced consumption of resources. Frédéric told us already, but I might just want to introduce a little bit more who we are. So we are originally from the Vorarlberg region in Western Austria. Currently, we are a team of about 250 people. But we are not working in one office. We are working in 14 different locations worldwide, and to work geographically in different places, meaning there where are our projects was a philosophical decision, because it gives us the opportunity to understand and face the physical as well as the cultural context in which we are working. You probably all know the slogan, think global, act local. So this is exactly how we see ourselves. We try to achieve a global knowledge by working together, but we apply it locally in consideration of the local context where we work. So today I will speak about a project of ours, which is called indeed 2226. You saw the headline and Frédéric just told us. where our declared goal is to combine less energy with less technology. And with the construction of our first 22-26 building, because there are many other buildings now, we did this decisive step, meaning with the most elementary means of architecture, the 22-26 building offers optimal conditions for the flow of energy. And I will show you in a minute how. The architecture of our building is interpreted as well in a completely different way, also from an aesthetic point of view. You will see that regarding its spatial and material quality, which, by the way, are the basic requirements we believe for a long-lasting building. And we believe that the 22-26 concept can be a way how buildings of the future can function. So when we ask ourselves the question, how to combine the comfort of our lives with the reduced consumption of resources, we have to understand our current context. And what is our current context? For once, we live in this moment in a society where we change from an industrial-oriented society to a service-oriented society. The question is, what does this mean in relation to architecture? First of all, the only thing it really means is that the future must be different from the past, because there is no other discipline mirroring the values of a society as much as architecture. You know that, because architecture is not an individual task. It always is a task where a lot of people of society are involved. Architecture never represents an individual thinking, but a collective thinking, including governments, investors, developers, citizens, engineers, artists, sociologists, etc. So the question is, what is really changing if we compare the beginning of the 20th century to the beginning of the 21st century? And if we look at these numbers from the International Climate Council, the contribution of the greenhouse gas emission in the maintenance of buildings is 18%. It's the violet part of the diagram. What the diagram does not show is more than 1/3 of the 33% of industry emission is also related to buildings. It is related to their fabrication. So together with the 1/3 of the industry emission, 32% of our CO2 emission is related to the fabrication and maintaining of buildings. So there is a first statement to do, that architecture is one of the biggest contribution to greenhouse gas emission. The second issue, which is quite important, is shown in this graph. You see, the blue line shows the growth of the average income in comparison to the red line, displaying the growth of real estate cost. They develop very differently, and there is a lot of social tension. This is a parallel development we can observe in many countries. And if we look at the reasons of this increasement of real estate cost, of course, the price of land plays an important role, something we architects can do nothing about. But we observe that one factor of that increase is, for example, enhanced technology. And it is not necessarily the investment cost in this technology, but it is its maintenance cost. Therefore, we at Baumschlager-Eberle asked ourselves two questions. First, how to make buildings more efficient in maintenance costs for the users. And second, how to increase the comfort of a building by reducing the impact of greenhouse gases of carbon dioxide. So when we speak about buildings in the future, we think we have to speak about comfort. Comfort in physical terms is about acoustics, humidity, air quality, and it is about temperature. So how do we understand a building? If you look at this graphic representing a normal building without any specific use, The blue line, the lower line, is the development of the outside temperature for 1 year. In this simulation, we are in Austria, in the area of Bregenz, for those who know, which is a quite continental climate. And the green line, the dotted line, is representing the inside temperature. The gray zone, in between the 20 and 25 degrees, the gray zone is where one seems to feel well. So when you see the red area, you know that you have to heat, in general, from November to April, at least in our area in Austria. And when you see the blue area above the gray zone, you know that you have to cool. So when, for example, you are an engineer and you look on the red and the blue zones, you know how big your machinery will be. We are architects, so we are not interested in the red or blue areas, but we are interested in the areas where you have to do, where you do not need to do anything. We are interested in providing comfortable situations for people, situations where you do not have to do anything inside the building, where you do not have to care about how things work. So what we were interested in over the last 20 years is a strategy how to optimize buildings only in an architectural and geometrical way. And when you do that, you get results like that, where the period where you do not have to heat or to cool are extended. And again, this optimization is only about architectural and geometrical questions. So we believe in every situation in the world, according to the local climate, you can optimize a building in relation to architectural questions. Here are some questions. So for us, the key question is, which is the most reasonable building in terms of architecture, and this in the context you built? And that's what we did over the last 20 years with the design of our buildings. When you want to optimize your building, you must optimize your design, and you can have a lot of different ratios and relationships and standards how to optimize your building. So now I show you our prototype building called 2226. It is quite a small building with 3,000 square meters of cross-floor area. It is a perfect cube, 24 meters high, 24 meters wide, 24 meters long. The location is not far from Lake Constance in Austria, in between Switzerland to the left and Germany to the north. And the site is quite interesting because I said it earlier, it enjoys a very continental climate, meaning it can undergo large temperature swings during a day and experience very hot and dry summers and very cold winters. The general layout of the building is quite simple. We have 4 big spaces around one central space, the vertical circulations. And how to use this space, in fact, history will tell us. For now, the use of the building is mixed. You might know Zumtobel, the big lighting company from Austria. They have 1 floor. We, the architects from Baumschlager Eberle, we have 2 floors. 1 area is rented for small companies, and 1 floor is rented as apartments. So we have a very diverse use in the building. So how did we do this building? And I have to start again with some graphics. This temperature graph shows the simulation of the 2226 building unoccupied. So again, it's a simulation and it is unoccupied. Again, the blue line represents the outside temperature over 1 year. The gray zone, you remember from earlier, is your comfort zone. And the green line shows the inside temperature of the building, again, unoccupied. Astonishingly, the inside temperature is always above 0 in the very cold seasons and quite fresh in the very hot seasons, like August, for example. Sorry, I went too quick. because it is very important. It was very important for us to understand how would be the temperature of the building when nobody is there, to understand the behavior of the building itself, because then only you can start on a second level to think about how will be the temperature according to different uses of the building. So now it's the second graph that shows the building now occupied, yet without any intelligent control system. And you see with the green line, we are approaching the well-being zone. Again, the green line is the inside temperature. And finally, now I show you this graph with real measured data from our 22 to 26 building in Lustenau. And we can see that the green line, the inside temperature inside the building, remains fairly constant between 23 and 24 degrees. So when we designed the building, finding a name was, of course, quite easy. We simply used the brief 22-26, no less than 22 degrees and no more than 26 degrees, as there is a common understanding or a common agreement all over the world that people feel comfortable with the temperature between 22 and 25 degrees. We allowed ourselves that one more degree, so 22-26. And all this without the use of any technical system whatsoever. No mechanical ventilation, no heating, no cooling system. This was a huge challenge, but also a very simple goal. So the main objective in constructing a building of this kind is not to disregard technology at all, or to do it without it completely. It is to maximize the comfort and well-being within the building. How did we achieve this? Again, only by architectural and geometrical solutions. They are the basis, but we achieved this in addition by making the building more intelligent, by using certain sensors and a software to optimize the temperature level inside the building all the year long. So in every room of the building, there are sensors about temperature, about carbon dioxide, and about humidity. And in the end, the software calculates what the building should do. So it is about to not put hardware in a building, but to work with a good software. When you calculate properly today a modern building using good glass, quite reasonable materials, a design with a reasonable percentage of openings and things like that, you will find out that only 20 to 25% of the energy demand of the building is related to the outside temperature. But 75 to 80% of the energy demand is related to the people, to the use of the building. Or in other words, if there are some engineers, I don't know, when we talk about the energy performance of a building, nowadays we talk about two phenomena. The one phenomenon is called the transmission losses and winds of the building. And the second phenomenon is called the ventilation necessity of the building. And when we do a proper building with the knowledge of our times, the impact that is determined by the transmission is only about 20 to 25%. So again, that relation to the outside temperature. But the impact that is determined by the use of a building is about 75 to 80%. So in this building, we said that we are not really interested in the transmission, but interested in the question of the ventilation necessity. When people use a building, we have to understand what people do to spaces. And again, in physical terms, people have four different impacts. The first is temperature. When you go into a building, first of all, you bring temperature with you. We are quite bad heaters, but we bring around 80 watt per hour. So if You might recall an old electric bulb that's approximately 80 watt per hour. That's the first thing, the temperature. Second, during one day, we people lose 1 to 1.5 liters of water. So if we are numerous in a building or in a space, we bring in a lot of humidity. And third, which is the most critical, the key issue, we do the opposite of trees. We take oxygen from the room and give back carbon dioxide. So we wanted to generate a building that reacts on the impact through the use of the building by the people, meaning, again, in physical terms, how many cubic meter of fresh air do we need in 1 hour, and how is the cubic meter of fresh air in relation to the temperature and the 80 watt you bring with you. And the secret is this: it's again quite simple. It's a good balance between the height of a room and the number of people in it. You all might remember a church visit. When you go to a full church, for example, the air quality is in general very good. And there is as well another important issue that relates to daylight. So the red line is the potential of use of sunlight in the building, and the blue levels, the blue areas, is when you need artificial lighting. The floor-to-floor height in our building, in the 22-26 building, is quite comparable to a normal office building. It's 3.60 meters. But since we do not commit 25% of the floor height to technical equipment, we have much more clear height than a normal building, and the light can go in much deeper. So it is very important to conceive a building that does not need artificial lighting all through the year. Only you can see it, of course, in winter time after 5 p.m., of course. So now I will show you how the building brings all of this together. So what can the building do? The building can do two things. It can open and close himself. So these are the windows with the opening flaps controlled by the software. The building can open and close the window, which, by the way, is very comfortable in use. But the user, the occupant, can override the control system and open the window himself, or forget to close them when he leaves the building, and the building will close them for you. The software, the control system, will do everything for you. You do not need to care about anything. So that's the first thing. And the second thing the building can do, the building can switch on and switch off the light. The artificial light in our climate is only good for heating, which we use sometimes in wintertime when the building is not occupied for a very long time. But in general, the heating values become so small that it is not really interesting. So the 22-26 building is only about opening and closing itself, and always in relation to your behavior, to the behavior of the users. And again, we do not work with traditional technical devices, but with a very intelligent control system, a system that is reacting on the CO2 content of the users, reacting on the humidity, and reacting on the temperature to keep the building in its balance. So instead of taking a complex technical ventilation system, there are those simple flaps in the window frames. They open automatically if the building becomes too warm or the air quality becomes too low. And in every room, one can monitor the influence of the occupants on the space. You can see the monitors here, and so everybody can observe, for example, the CO2 content, the temperature, the humidity of the air in the building. And the idea of comfort is very important. If you want to change something, you as a user, if you want to open the window, you can, and the building will rectify over one day. And if you do not want to care about something, the building will do it for you. Now you can see again measured data according to different people in the room. And here during 1 month, you see the red line measures the carbon dioxide in the air inside the building. The blue line again is the outside temperature, and the green line is the inside temperature. And then you see that the green line of the inside temperature is only depending 0.5 degree on all of this for 24 hours. And if you lower the occupancy, you get this. Again, measured data of a big space with only 1 person in it. By the way, this is the measured data of the office of our founder, Dietmar Eberle, who has a big space by himself. And you can see that the temperature does not change. So as a result, the only energy consumed is the electricity used to operate the lighting, the computers, and the coffee machines. And the energy consumption is currently around 40 kilowatt per hour per square meter per year. We could even, I think, compensate and bring the consumption almost to 0 with a photovoltaic central on the roof, which we didn't do yet. The construction of the 22-26 building is very simple. Everything horizontal is in concrete, so all the slabs. This is the most important storage for keeping the mass activated. There are no suspended ceilings. The space needs to be in contact with the concrete. Again, the concrete is the storage mass. And everything vertical is in brickwork. You might ask, is the project better insulated as a normal building? And you have to know that there is no additional insulating material at all. It's just the bricks, the standard vertical coring bricks one takes for average buildings, and the void of the bricks with the air inside brings enough insulation. Though there is one difference you can see on the left of this slide, the bricks are double layered, and therefore the exterior wall is quite thick with 72 centimeters. And on the brick, so on the exterior wall, there is lime plaster, kalkplaster, with stones from the local mountains heated up to a temperature of 100 degrees, then plunged into the water where stones break to form the plaster, like it has been done for centuries in that area or in monasteries, for example. And you can see some use of this lime plaster and its architectural beauty. We're still talking about architecture as well. And talking about the lime plaster, I have to say that the materials used in this building play a major role in creating a comfortable environment. And they all share one common characteristic. They are able to absorb and store a certain amount of heat and then release this heat together with humidity back into the space. The materials are all locally available and come from a perimeter around 30 kilometers around the location. All the material used in the building are natural, meaning without any toxic emergence. For example, you see everything is white, but there is no paint in the building. Again, this is the natural lime plaster. Some other views with different atmospheres. And here we can see the restaurant on the ground floor. And the restaurant, for example, is quite interesting because sometimes there are about 100 people in it and the data doesn't change. So very different things happen in the different rooms and you do not have to do anything. And I would like to start the conclusion with this massive wood furniture, this table we have all over in our office. These are tables designed by Dietmar Eberle, because these are tables without nails, without screws, without glue. Just to say that in architecture, it is just about the knowledge how to put things together Again, the secret is the knowledge about how to use architecture in its pure geometrical and design approach in order to achieve a true change in building performance. And we believe that sustainable development is an issue that cannot only be solved with technology alone. The 2226 building, again, with no mechanical system, no ventilation, no heating, no cooling, leads to a reduction of energy consumption of 67%. And as a result of this strategy, without building equipment, the construction costs, of course, was also reduced by 20 to 25% in comparison to a standard property. And the real important value is that the life cycle costs are, believe it or not, almost 50% below comparable buildings. And that represents a dramatic change in the performance and offers a new perspective for future realizations. So in order to reach that goal, we must understand that architecture is not only related to the design of a building, but to the creation of a relationship to the context and the use of the building. And yeah, because in the end, we think to build is really an act of culture. So thank you very much for your attention. That's